Hey everyone, and welcome to The Explainer. Now, today we're going on a truly mind-bending journey. We're going to tackle one of the absolute hardest, most stubborn concepts in all of quantum mechanics. For decades, the greatest minds in physics have wrestled with a phenomenon that literally seems to break the rules of reality. But today, we're looking at a completely radical, fresh framework that might just solve the whole thing. How? Well, by asking us to rethink the universe itself.
Okay, let's dive right into this. If you know much about quantum mechanics, you've probably heard Albert Einstein's famous quote. He looked at how two entangled particles could instantaneously affect each other. Even if they were light years apart, and he just called it spooky action at a distance. It was a massive dilemma, like how on earth can one particle communicate with another across vast expanses of space with literally zero time delay? It challenged the very foundations of how classical physics tells us the world works. And honestly, it's a cold case that has haunted physics ever since. To get to the bottom of this, we'll be covering the entanglement paradox, an illusion of space, the same field's interpretation, universe as informational order, reimagining quantum teleportation, and finally, the future of reality. It's a roadmap that'll guide us step by step through a completely fresh way of looking at things.
So, starting off with section 1, the entanglement paradox. We need to set the stage here with the core issue of non-locality and realism that has just stumped classical physics.
For years, traditional interpretations have really struggled to resolve this intuitive difficulty. You've got the standard Copenhagen view, which basically just shrugs its shoulders and accepts instant correlation as an unavoidable, kind of weird fact of nature. Then, on the other hand, physicist David Bohm attempted to explain it using a hidden quantum potential that connects everything. But here's the thing. Both of these views share one massive underlying assumption. They both assume physical space is an absolute reality, and that these two particles are genuinely separated by an actual physical distance.
Which perfectly sets up section 2, an illusion of space, because we are about to drop a bombshell about spatial separation itself.
What if the problem isn't the particles at all? What if the problem is space itself? What if spatial separation is literally nothing more than a trick played on us by our own brains trying to make sense of the universe? This paradigm-shifting concept comes from Masashi Awata. He is an independent researcher from Japan. And what makes this so fascinating is that Awata is tackling Einstein's paradox from entirely outside the conventional box. By stepping away from the traditional constraints of physical substance and bringing in cognitive science and information theory, Masashi Awata proposes a framework that fundamentally rewrites the rules. Let's move right along to section 3, the same field interpretation. This is the absolute core of Awata's breakthrough solution. Here is the defining concept. The same field isn't some invisible physical blanket stretching across the universe. Instead, it denotes the simultaneous occurrence of events beyond our perceptual separation. Basically, entanglement isn't a mysterious action traveling at warp speed across a massive distance. It's simply one event happening simultaneously in a unified field. The particles are actually just different aspects of one single informational block, fundamentally undivided. And this brilliantly illustrates the massive contrast here. In the traditional view, you have physical reality, right? Particles are physically separated, and we are forced to imagine them communicating instantly through some totally unknown mechanism. But in the same field view, spatial separation is just a cognitive construct. Think about that for a second. Distance is literally in your head. The particles aren't separated at all. They're bound together in a single informational event, completely bypassing the need for physical travel. This perfectly aligns with physicist John Archibald Wheeler's famous it from bit perspective. He suggested the universe is fundamentally made of information, not just physical stuff. Awata's interpretation really deeply resonates with David Bohm's holistic worldview, but it completely reformulates it through the lens of information theory. The universe isn't just a collection of separate physical objects scattered across some empty void. No, it's a higher-order informational structure where everything is intrinsically connected. Moving into section 4, universe as informational order. Don't worry, we're not going to get bogged down in dense math here. We're going to look at it as a beautiful story of informational order. Think of this like cracking a code. In step 1, before we look at anything, the entangled particles exist in a pure state represented by a density matrix. Here, total informational order is perfectly conserved. Physicists call this a von Neumann entropy of 0. But then, step 2, an observer measures one of the particles. Mathematically, this is called a partial trace, which essentially means we're mathematically ignoring the rest of the system and discarding the information of the other particle. This leads directly to step 3, where the system projects into a mixed state. The uncertainty we perceive in the world suddenly emerges. So measuring one particle naturally affects the whole simply because they were always just one single unbroken informational block. So the crucial point is how this completely changes our view of Bell's inequality. For decades now, physicists have used the violation of Bell's inequality to prove that non-local spooky influences must exist. But Awata argues that Bell's inequality was built on a flawed assumption to begin with, the assumption that particles A and B are independent entities. If we remove that assumption, because again, distance is a cognitive illusion, the violation of Bell's inequality actually proves Awata's point. It proves they are completely inseparable and part of a unified informational field. Now let's look at Section 5, Reimagining Quantum Teleportation. How does this actually change our practical understanding of cutting-edge science? Well, it brings up a massive question. What does this mean for quantum teleportation? If distance isn't real, and these particles are just information, how do we explain the very real experiments where scientists are literally teleporting quantum states from one lab to another, across entire cities or even up to satellites? Under Awata's framework, it's incredibly elegant. Quantum teleportation is not the physical, spatial transfer of a particle from point A to point B. Actually, scratch that, it's nothing physical traveling at all. Instead, it is simply the reconfiguration of an informational block within the exact same field. Superposition, entanglement, and teleportation are really just manifestations of hyper-efficient information processing happening within this unified basis. It completely simplifies our view of quantum information science, basically turning physical travel into a mere software update in the universe's code. Which brings us to our final section, Section 6, the future of reality. Where exactly does this bold interpretation lead us next? Let's move to and see how this builds out Awata's ambitious future tasks. First, physics needs to integrate this informational interpretation with our understanding of gravity and space-time structures. Second, we need to design novel experimental protocols to indirectly test and actually prove the existence of this same field. And third, we get to examine its philosophical consistency with non-dualism, which is the ancient idea that all things are fundamentally one. Which leaves us with this final, staggering thought. If quantum entanglement is just a single informational event, and if spatial separation is merely a cognitive construct generated by your brain to make sense of the universe, is the physical space around you truly real? Or are you and literally everything you see simply different aspects of one singular block of information? It is a framework that completely reshapes how we understand the cosmos. Thanks so much for joining me on this deep dive. Keep questioning, keep learning, and I'll catch you in the next explainer.